This lesson is about one important but a little weird concept of generators. Generators are iterators, and we will also discuss in detail the difference between iterator and iterable. I will be using the term iterator and iterables many times in this lesson, and then there is the term iteration, so be a little careful to differentiate between these terms. Examples of iterables are list, tuple, set, dictionary, etc. And in last lesson we studied about zip, map and filter functions, and those functions return an iterator. So we will conclude our discussion on difference between iterator and iterable in that context as well. To start with the discussion on generators, instead of going into the detail of why to use generator or the different ways and the syntax to create a generator, let's straight away see an example and you will realize why generators are so important. Suppose I want to find the sum of first 1 million integers. So here I have created a list of 1 million integers using the list comprehension and range function. The integer 1 million is not included in this range because numbers generated by the range function does not include the last specified number. But let's say we don't want that to add either. Then I am using the sum function to get the sum. Let's run the code, and this is the sum of the numbers. Now I will do the same thing by creating a generator rather than a list. For that, instead of the square brackets, I will use the parentheses. It looks like tuple comprehension, but recall from the lesson of comprehension that we have list comprehension, set comprehension, dictionary comprehension, but we do not have the tuple comprehension. Let's first see the data type of this object B. See that it is an object of class generator, so B is a generator. And let's apply the function sum on B. And see that we get the same result with list and generator. But let's compare the sizes of both list and generator. See that it is more than 8 megabytes for the list and just 112 bytes for the generator. And that's why generators are something that can make a huge difference. Instead of 1 million, if you will go for the sum of 100 million integers, you will see the size of list as more than 835 megabytes or more than 0.8 gigabytes. And generator will have the same 112 bytes. If still not convinced, you can try on 1 billion integers at your own risk, because if you have just the 4 GB of RAM, your computer might get stuck. But in case of generator, it will be the same 112 bytes even for 1 billion integers. So this is a huge advantage of using a generator and a big motivation to understand the concept of generators. We will discuss about the difference between the time of execution of list and generator after a while. This method of creating a generator object, which is exactly similar to comprehension technique, is known as generator expression. There is another way as well known as generator function, and we will see that after a while. Of course, we can directly create a generator using the generator expression inside the function sum. This is the generator expression, and see that we have two consecutive opening parentheses and two corresponding closing parentheses as well. This will be the case whenever we are creating a generator expression inside some other function, for example function sum here, or directly inside the print statement, or maybe the max function or the min function or any other function. In such case, Python allows us to use just one set of parentheses. Now let's explore a little detail of generators. Here I have created a generator object with numbers 0 to 9. We saw we can use the function sum on generator object, but now let's apply the for loop on the generator object. We get the individual elements on each iteration of the for loop. Now let me print the same thing one more time. See that nothing is printed in second for loop after the line number 4. This is because a generator object is an iterator. So we will have parallel discussion on difference between iterator and iterable as we will move ahead in this lesson. A list is an example of iterable. A generator is an example of iterator. The first difference between an iterator and iterable is that an iterable, for example, a list can be used as many times as we want. But on the other hand, an iterator, for example, a generator, can be used just once. because an iterator produces the elements on fly when demanded. For example, in each iteration of the for loop, one element of the iterator is produced, and once an element has been produced, the iterator cannot produce that again. So in first for loop, all elements inside the iterator, which is the generator object A, were produced, and at the end of the for loop, the iterator became empty. We say that iterator has been exhausted or completely consumed, and hence in second for loop no element was produced. The same is true for any other iterator, for example the map object, the filter object and the zip object we studied in the last lesson. Suppose here I have a list of numbers and I want to get the squares of all numbers. So one way can be using the list comprehension and creating those squares inside the list B. And there could be a possibility of using the map function and mapping the square function on all elements of the list A. In case of a map function, the map will not apply the square function immediately and it will not have all the squares available as in case of list. In list, all squares are available readily, but in the map object, the squares are not available readily and they will be generated on demand. And at that time, the map function will apply the square function. For example, if I will apply the for loop on the map object, the map will produce one element in each iteration. I will discuss in a second how map or any other iterator produces one element in each iteration of the for loop. Or it can be some function, for example function sum. And if we pass an iterator, the elements inside the iterator will be produced at the time of execution of the sum function. So in short, in an iterable, for example a list, elements are available readily to be used, and in case of iterator, the elements will be produced when needed. Just recall the first example we saw in this lesson, that in case of list, when we were increasing the number of integers, the size of the list was increasing, but the size of the generator was same 112 bytes for any number of integers. Why? Because in case of list, all integers are available physically inside it and hence has a larger size for larger number of integers. While in case of generator, there is no integer inside it. The generator object just knows how to produce the next integer and will produce that when needed. And that's the reason behind so much less memory of generator. Instead of map, we can also use generator in this case, which will produce the elements on demand. Now let's see how internally the elements of an iterator are produced when demanded. Let me change this list B name as X. Now let's see different functions which are available for a list object, which is an iterable, and for a generator object, which is an iterator. We can view that by using the dir function, and I have a line of hyphens in between the two outputs. These are list of different functions for the list object and the generator object. In case of generator, we have this method _next . The methods rounded in between double underscores are special methods and are also called as dunder methods. You can say that these methods are for the internal use, although we can use these if we wish. The detail of dunder methods will be discussed in object-oriented programming. Anyways, the generator has this method dunder next, and we don't see this method in case of list. This difference is important to keep in mind while discussing the difference between iterable and iterator. Another thing you should notice is that iterator have this method dunder iter, and we have the same method in case of iterable as well. By the way, there is no class directly with the name iterator. I mean, we cannot say that some object is an object of class iterator. The objects of some class can be iterator. For example, the map object is an iterator, generator object is an iterator, and also the filter and the zip object. These are objects of their own classes, but are iterators because their classes follow the iterator protocol. Now, what is this iterator protocol? Any class having the two methods dunder next and dunder iter is a class following the iterator protocol. So for example, the map class or the generator class has the definition of dunder next and dunder iter, and hence the objects of map or generator class are iterators. You can verify for these two methods in all these classes, and hence their objects are iterators. The function dunder next is the one used to produce the element from an iterator. This is done internally, but we can also use this function, and for that we simply call it by the name next, and double underscores are not needed. So let's print the output when function next is applied on the generator B. The output is 25, which is the square of 5. and it means the first element has been produced from the generator. Let's apply this one more time. And the next element produced is 9. Let's use the next function 5 times since the generator B can produce 5 numbers. And the 5 numbers are produced. With next function used 5 times, all 5 numbers have been produced, and after that the generator is exhausted or fully consumed. Let's see what happens if we try to produce one more element from the generator. See that 5 elements were produced, and on the 6th attempt we got this error stop iteration. And hence an iterator, for example a generator, is one time usable. We don't have this function next for the iterable, for example a list. Read the error message that list object is not an iterator. Now when a for loop is applied on an iterator, the function next will be applied internally and that will produce an element in each iteration. And that will be assigned to the loop variable. That's how a for loop works on an iterator. But it will be important to see how a for loop works on an iterable because we saw that we don't have the function or method next for iterable. And we also know that we can use the iterable multiple times without any fear of iterable getting exhausted. Recall we saw that there is a method named as iter in list class and is also there in any other iterable. What this does is that when applied on an iterable, for example the list x, it will return an iterator, and that iterator is used in the for loop when applied on the iterable. These are the things Python does when we apply for loop on the iterable, for example a list. It will call the iter method on the iterable and will obtain an iterator against that. Then it calls the next method on the iterator to get each element from the iterator in each iteration, as we discussed earlier. And the loop variable I gets the value produced by the function next. So the important thing is that next function is not applied on the iterable, but it is applied on the iterator, which is produced by applying the iter function on iterable. And Python will terminate the loop when next method raises the stop iteration exception, meaning the iterator is exhausted. And that is why we can use the iterable as many times as we want, because each time we use the iterable in a for loop, a new iterator is created. Just to give you one simple example for difference between an iterator and iterable, consider here one juice box and one vending machine with almost infinite supply of juice boxes. The iterator is like one juice box. You can consume the juice, and once completely consumed, the juice box is empty or exhausted. On the other hand, the vending machine with the infinite supply of juice boxes is like an iterable. You need a juice, you can take one, and if you need more, you can take as many as you wish. And each box is having exactly the same content. Similarly, from an iterable, we can create as many iterators as we need, having the same elements inside it. Let's discuss a little more on difference between iterator and iterable, and then we will continue the discussion on generator. Firstly, an iterator is also an iterable. Remember how we defined an iterable in early lessons? We said these are the objects which can be directly iterated over using a for loop. And we know an iterator can also be directly looped over, and hence an iterator is also iterable. Although an iterator can be looped over only once, but still it can be directly looped over, and hence an iterator is an iterable as well. But reverse is not true. We can apply min, max and the membership operator in on the iterator as well. We can also unpack the elements of an iterator just like unpacking the elements of an iterable. Now let's see that we can convert an iterable object into an iterator. For example, A is a string. We can use the iter method to convert that to an iterator. I am printing the type of variable B and then is the for loop. First see that it is an object of class str_iterator. Recall I mentioned earlier that we don't have a class with the name iterator, and here when a string is converted to an iterator, the class name is str_iterator. Likewise, if you will convert a list into iterator, the class name will be list_iterator, and you can verify others as well. Similarly, we can convert some iterator into iterable using the respective constructor. We can convert the generator A to a list using the list constructor. By doing so, all elements inside the generator A are produced and are stored in the list X. And then we can use the list as many times as we want. But of course, we will not get the advantage of less memory in this case, because list will not take the less memory. Just to conclude our discussion on iterator, note that these objects are iterators. And the file objects we studied earlier also create an iterator. This is one timestamp of the lesson on reading CSV file. The link of the lesson is also given in the description. See that R is a dict reader object, and when we used that inside the list comprehension of list LA1, it was consumed completely, and when we tried to use the same object R second time, the list LA2 was empty. So what we did was, we created a list from the file object R, and then we can use that multiple times. Just watch this little part of that video again when you finish this lesson. So this concludes our discussion on iterator and iterable, and now we will continue our discussion on generators. We saw one method known as generator expression, and its syntax is exactly as of the comprehension technique. Then there is a second way we can create a generator, and that is by the generator function. Here I have a simple function which at the moment is not a generator function. We have a for loop running for n number of times, where n is the input argument. We are returning I, the loop variable, inside the for loop body. I am sure you can easily see that this for loop will always return the value on its first iteration. The loop will never go beyond the first iteration. In first iteration, the loop variable I is 0, and for any positive input value, the function will return 0. Here we are applying the function on value 5, and we get the expected output 0. If input is 50, the output again should be 0. Let's apply it on 3 different values, and output should be 0 for all 3 cases. Now instead of this return statement, if I use the statement yield, then this function becomes a generator function, meaning that when we will call this function, it will return a generator. Let's run the code which previously gave the output as 0 for all 3 cases, and this time you can see that it is a generator object for all 3 cases. Don't be confused from the memory location which is same for the 3. It is because we are not assigning the generator object to some variable. If you will assign the 3 generator objects to 3 variables, for example variable a, b and c, and then will print a, b and c, you will see the different address. Now let's focus that the function returned a generator object when we use the yield statement instead of the return statement. Let's have just one call to the function for input 5. So a is a generator here. Let's produce all elements inside generator A. And these are numbers 0 to 4. So it seems that this for loop has completed all iterations this time, while previously it had just the first iteration. The reason is the way a generator function operates is quite different from how a normal function operates. In a normal function, whenever we call the function is executed from the beginning. But in case of generator function, when we call the function here, the function itself is not executed. It is just the information stored in the variable a, which is generator, that the function test should be used to produce the elements when demanded. So when the method next will be called on the generator object a, then the function test will be executed to produce the element. Secondly, when the second element will be produced using the method next, the function test will be executed, but not from the beginning, but from the point where the first execution was ended. It is unlike the normal function, which always starts the execution from the beginning. So in case of generator function, whenever next element is needed to produce, the function will start its execution from where it was left in the previous execution. That's why the generator functions are also known as resumable functions. Let's see that in step-by-step mode for clarity. The function is called and it will simply create a generator object. You can easily see that interpreter did not enter into the function body. Now is the for loop that will produce the elements of the generator. And for that it internally uses the function next, and that will execute the function test to produce the element. You can see now interpreter entered into the function body. N is 5 and loop variable I will get the value 0. This yield I will provide the element I which is 0. So now interpreter is in the main program and loop variable I here got the first value from the generator A which is 0. It will execute the body of the loop and will print the value. Now is the second iteration of this for loop and second element of the generator is needed. It will apply the method next internally, and that will execute the function test to produce the next element. This was the last statement in previous execution of the function, and this time the function will resume from here. I mean from the next statement after this line. The next statement after this line is the for loop statement, and you can see the interpreter moved there. Apparently it is not a good case to see the function resumed from the last execution, because this statement is also the first statement of the function as well. So you might be thinking that function is being executed from start as any other normal function. But see this local variable window, and value of variable I is already 0, which was the value in previous execution of the function. And when we move to the next step, see that the value of the loop variable is 1, which obviously means that it is the second iteration of this for loop. So this for loop had the first iteration when first element was produced, and now when the second element is produced, this loop is executing the second iteration. This yield will provide the element produced to the main program. Here the loop variable I got the value 1 from the generator. I'm sorry that I'm using the same loop variable name I for both loops, the loop of the main program and of the generator function. But I hope you are well familiar with the concept of local variables, and both variables I are independent of each other. In a minute I will show you one more example for further clarity of the resumability feature of the generator function. Anyways, here the function body will be executed and will be the next iteration of the for loop. Now it needs the next element, which will be produced from the generator function again, and that will resume its execution from the previous point. And I will just end it here. And now we have another example of generator function to see the resumability in a better way. Inside the function I am first printing letter A, then is a while loop that input argument n is less than 3, then a yield statement, increment in value n, then another sample print statement printing the letter B, and finally printing letter C outside the while loop. In main program I have created the generator object by providing the value of n as 0, and then I have used the next method a couple of times to produce elements inside the generator. The generator is created, it is printed as generator object, and see that example is written here, which is the name of the generator function. Now we are calling the function next on generator A, and that will execute the generator function. For the first time, of course, the function will start from the beginning. Now is the yield n with n as 0, and that's the element produced. So interpreter will move to the main program. The variable x got the value of the first element inside the generator, which is 0. Now we are calling the next method again. This will execute the generator function to produce the second element. Before I press the step into button, see that this was the last statement executed when first element was produced. And when I press step into, see that function resumed from the last point rather than the beginning of the function. So it will increment the value of n, will print letter B, then will be the next iteration of the while loop, and this yield n will provide the second element to the main program, which is 1. X will get the value and is printed. Now third time next is called, and it will produce the third element the same way by resuming from the last execution of the generator function. The third element is produced and returned. Now we are trying to produce the fourth element. It will resume from there. The while loop condition is false this time, so it will come out of the while loop. This is the last statement of the function. Yield statement is not executed this time. Let's see what happens. And we get the stop iteration error because no element was produced. Basically the value of n is 0, and according to the while loop condition we can produce 3 elements from the generator function, and hence when we try to get the fourth element from the generator, it gave the error. Now once you know the working of iterator and iterable, it's quite easy to understand that in terms of time consumption, there is not much difference between the two. Sometimes you might get iterables giving the results fast, and sometimes the iterator. Suppose our list is created by applying a function f on each element of the collection. Now suppose that the function f takes noticeable time to compute the output. So overall this list comprehension will take reasonable amount of time since it will apply the function f on each element of the collection. But once the list is ready, applying a simple for loop on the list will take no time because all elements inside the list are already calculated. But if we will do that using a generator, we know it will apply the function f when it will produce the element on demand. So creating a generator will take no time. But when we are iterating over the generator object, During the loop iterations, an element will be produced by applying the function f in each iteration. So the loop iterations will be slower in case of generator because elements does not exist readily and will be produced by applying the function f, which we said takes a noticeable time. And that is why the iterators are also called as lazy iterables. But you can see overall time of execution of the two approaches will be close to each other. Now here I have a function getSquare which will take one list of numbers as input argument and I want to get the square of each of the number. So this generator function is yielding the square of each number inside the input list. Actually I want the sum of all squares of the numbers inside the list. This is a sample list. Here I have created a generator object. Let's just execute this part of the code. It's the generator object with the generator function getSquare. Then I have applied the function sum on generator and we get the result. The advantage of generator function here is again the less memory. If you will be doing it as list comprehension, all squares will be inside the list, and if we have so many numbers inside the original list, the squared list will consume a lot of memory. But we just need the sum of the squares and not the individual squares. So generator function is much better option here because for this case the elements will be produced one by the function sum and we will get the answer. Of course, instead of generator function, we could use the generator expression in this case. Now in this generator function, we have an infinite while loop. Inside the loop, we are yielding the value n and increment that by 1. So basically this generator function is capable of producing as many integers as we wish. Let's create a generator object. If I use the for loop on it, it will produce the numbers inside the generator one by one, but that generator can produce infinite numbers, so I will put a break statement. So it will execute the for loop 11 times, producing the 11 numbers 0 to 10 from the generator. Let's apply the for loop again on the generator. This time we will not get the blank result because the generator object has not yet been exhausted. So actually the 12th element and the next elements will be produced by this for loop. Again I will put a break statement. See that first loop produced the numbers 0 to 10 and then the second loop produced the next numbers because the generator was not exhausted. And in fact this generator will never get exhausted. So if I call the function next after the two for loops, it will produce the next number from the generator. So that was all about the generator function. We saw we can use the generator expression or generator function to create a generator object. Which of the two we should prefer? Personally, I will try to use generator expression most of the time since its syntax is exactly of the comprehension technique and that is very commonly used. But if there is some lengthy calculation to produce an element, like not simply the square of a number but some lengthy calculation needed on a number, then I will use the generator function. Although we can use generator expression in that case as well. One last thing here is a function which is a normal function and not the generator function because it has a return statement and not the yield. But the thing it is returning is a generator expression. So essentially when we will call this function, the output will be a generator object. But of course that generator object will not be using this function to produce the elements, so technically we will not call this function a generator function. So that's all from this lesson. Thanks for watching.